Okay, so far we've looked at situations where you have two sets. Now I want to look at situations where you have three sets. So we're going to have an example here, and then we're going to work through that to find our answer. Now, here's the question. A group of 40 tourists in Victoria Falls were asked which of the following experience they enjoyed. So they were asked which of the following experiences they enjoyed. There. Game viewing, the waterfalls, or the casino. So they were asked, there were 40 tourists, and each of one of them was given a questionnaire, and they were going to tick off which of the activities or the experiences they enjoyed. Each tourist could tick 1, 2, or all three. They could pick, if they enjoyed all three, they could pick all three. If they enjoyed only one, they could pick only one. Now, 7 said that they enjoyed game viewing and the waterfalls. So 7 said they enjoyed game viewing and they enjoyed the waterfalls. 5 said they enjoyed the waterfalls and the casino. 6 said they enjoyed game viewing and the casino. 17 said they enjoyed the game viewing. 22 said they enjoyed the waterfalls. 15 said they enjoyed the casino. So this is 17. They didn't say they enjoyed game viewing only. This was just the total number of people who mentioned game viewing. They could have mentioned waterfalls or casino as well. Same here. This is the total number of those who said they enjoy waterfalls. They could have enjoyed casino and game viewing as well. Applicable here as well. 15 represents the total number of those who enjoyed casino, who could have also enjoyed waterfalls and game viewing. And so all the tourists enjoyed at least one. So there's no tourists who said they enjoyed 0 of the events. So the tourists actually enjoyed 1, 2, or 3, all of them, 1, 2, or 3 experiences. Now, let's look at the question. The question is, how many tourists enjoyed all 3 experiences? How many tourists enjoyed all 3 experiences? And so what we want to do is get our data all set. Let's look at our data here. First of all, the number, we're going to start from the top there. 7 said they enjoy game viewing and waterfalls, right? So the number of those who enjoyed game viewing and the waterfalls is going to be 7. And then 5 is waterfalls casino, 6 is game viewing casino. So waterfalls and casino, 5 enjoyed. And then game viewing and casino, how many were those? It's 6. From there, 17 said they enjoyed game viewing, 22 waterfalls, and 15 casino. So 17, 22, 15. So you have 17, 22, 15. And what's the order there? Game viewing, waterfalls, casino. Number of those who liked game viewing. Number of those who liked waterfalls. Number of those who enjoyed the casino. So now the number who enjoyed all 3, right, would be people who belong in the intersection region of the game viewing, the waterfall set, and the casino set, and we don't know how many that is, so we'll call it X. So now let's take this information and then put it on a Venn diagram. Let's take this information and put it on a Venn diagram. So we'll have our boundary, our rectangle. This is going to be the Venn diagram boundary. Then we're just going to have our 3 sets. We have our first set for casino, for game viewing. Just put game viewing, put different colors for the sets to make it clear. And then we'll have our second set for waterfalls. And then we'll have our third set for the casino. And now, what do we know? The first thing we know is the number of people who enjoyed all three is X. So I look for the intersection region, a point or a region that's inside all three sets. So this part here is inside all three sets. This region here is inside the game viewing set, the waterfall set, and the casino set. So this is where I put my X. X number of people enjoyed game viewing, waterfalls, and casino. Now we're going to work outwards from there, right? Using the information we have there. The number of people who enjoyed game viewing and waterfalls is 7, right? So I go on and check for the region. This region here is the intersection region for game viewing and waterfalls. And we're told the total number of people sitting in this region is 7. So if I removed X and put X here, the remainder there will be 7 minus X in that region there. 7 minus X there. If there's X here, I'll have 7 minus X. Such that if I add this, 7 minus X plus X minus X plus X gives you a 0, 7 plus 0 gives you a 7. So it's true that this region amounts to a total of 7. So I've put this information on the Venn diagram. The next thing is number of people who enjoyed the waterfalls and the casino is 5. So I go to the intersection region of the waterfall now and the casino. So this is the region, right? So if there's a total number of 5 and I removed X there, the remainder here will be 5 minus X. So there's 5 minus X over there. And then get my information again. Number of people who enjoyed game viewing and casino is 6. So I come this side here. This is where I'm going to have my 6 minus X. So I've completed this first part of the Venn diagram. Now I have these parts here. This part here, this part here, and this part here. This part here does not intersect with any other region. So people who are sitting in that region enjoyed game viewing and nothing else. People sitting in this region enjoyed waterfalls and nothing else. And then people sitting in this region enjoyed the casino and nothing else. And so we have to make calculations, right? The total number of people who enjoyed game viewing is 17, right? Total number of people belonging to this set of game viewing is 17. So what do? We have to calculate how many enjoyed game viewing only. So number of those who enjoyed game viewing only is going to be 17 minus all the other regions of that set, minus 7 minus X minus X minus 6 minus X. So you have a total of 17, you subtract this, that, and that, then you get your remainder that you're going to put there. So minus 7 minus X minus X minus 6 minus X. Minus 7 minus X minus X minus 6 minus X. So this would give you 17 minus 7 plus X minus X minus 6 plus X. This will give you 17 minus 7, that's 10, minus 6, that's 4. Then you get your 4 plus X. So number of people who enjoyed game viewing only and nothing else is 4 plus X. Now we can do the same calculation to find the number of people who enjoyed the waterfalls only and nothing else. So number of people who enjoyed the waterfalls only and nothing else. I would have to say the total number of people who enjoyed the waterfalls was 22. So I'll take 22 and subtract all the other regions, right? This is the set for waterfalls. I want to find the number of people here. So if the total is 22, I'll subtract these ones, this one, and that one. 7 minus X, X, 5 minus X. So it's 7 minus X minus X minus, minus 5 minus X. 5 minus X. So this will give you 22 minus 7 plus X minus X minus 5 plus X. So this will give you 22 minus 7, that's 15. 15 minus 5, that's 10. And then I'll have 10 plus X. So those who enjoyed the waterfall only is 10 plus X. So finally, we want to look for those who enjoyed the casino only. Those who enjoyed the casino only. So you have to look for the total number who enjoyed the casino, which is 15. Then you subtract the other regions, right? So number of those who enjoyed the casino only is going to be 15 minus the other regions. So it's 15 minus 6 minus x minus 5 minus x for you to find the remainder. Remember, the total of this set is 15. So you subtract there, there, and there. So minus 6 minus x minus 5 minus x minus 6 minus x minus 5 minus x. So this gives you 15 minus 6 plus x minus 5 plus x. So 15 minus 6, that's 9. 9 minus 5, that's 4. Then you get 4 plus x as your answer. So you have your 4 plus x there. Right. So now when you're here, your Venn diagram is complete. Since we're told there's no one who enjoyed nothing, 0. Each tourist enjoyed at least one of those. We don't have to worry about the region outside those 3 sets. So what do I know now? How big was the group of tourists? The group of tourists was actually, if you go back to the question, was 40. There were 40 tourists in total. This means that my universal set contains a total of 40. If I take this back up there, it means that if I add everything in here, my total should be 40. If I add everything in here, my total should be 40. So let's work on that. Let me just remove this, then use this space. Just remove that and then use this space. So my total should be 40. My total should be 40. If I add everything here, so 4 plus x plus 7 minus x plus 10 plus x. 4 plus x plus 7 minus x plus 10 plus x. And then plus x plus 6 minus x plus 5 minus x plus x plus 6 minus x plus 5 minus x plus 4 plus x plus 4 plus x. This should give you 40. So if you add up everything in the universal set, your answer should be 40. So if I add up the numbers, 4 plus 7, that's 11, plus 10, that's 21, plus 6, that's 27, plus 5, that's 32, plus 4, that's 36. So you get your 36. And then x minus x, 0. X plus x, 2x minus x gives you an x, minus x gives you 0 again, then you get a plus x. So 36 plus x will be equal to 40. I've simplified everything to just 36 plus x. Take my 36, that other side becomes a negative. So x is equal to 40 minus 36. This means x is equal to 4. So what does that mean? There are 4 tourists who enjoyed all 3 experiences. They enjoyed the game viewing, they enjoyed the waterfalls, and they enjoyed the casino.